So what in the physical state of thought? What is the search of your emotions, or decide making, or patience, or pains, and everything else? Well, it is the brain, and it's said to be the most complex mechanism in the known universe. Your mind expects, given all it is and given all it does, that will look very pretty. Philips, shimmering light and glass types and mysterious colors. But in fact, it looks really kind of gross. It looks in a 3D walled metal loft. It's grey when you take it out of the head, and inside the head it's bright red because of all the blood. In fact, it turns out very surprisingly that the search or your mental life of your confusions is mad. In fact, you could eat. People have eaten brains. I've had brain with cream saints, not human brain, mind you, but I've had brain with cream saints. It's not bad, but it makes the puzzle all the more headed. How this fleshy thing give rise to mental life? That's the questions I want to explore in these lectures and the rest of the lectures. I want to do so by starting with the smallest relieved parts, different parts of neurons. Then explore how the neurons are connected together, and how they're wired up, how they form different subparts of the brain, like the hypothalamus and the frontal lobe. Finally, talking about the brain and the larger perspective, look on the two halves on the brain, the left half and right half, and how they interact. Now there's a lot of stuff in the brain, a lot of chemical stuff, a lot of different parts. By the way, action is the part that does the thinking. The part that is the focus of most of your search in the neurons. It's now one accident they call the study of the biological basics of thought neuroscience, because it all comes from the neurons. So you can see here pictures of neurons interacting tonight. Here a diagram that depicts a typical neuron. So what we see is the dendrites, and the dendrites receive signals from other neurons, either exploratory, like pluses of inhibitory minuses. Then they get to the said body, which terms in the pluses and minuses. When you teach a certain amount of pluses, the neural firing takes place through the axon, and the axon is much longer than the dendrites. In fact, for some motor neurons, it's very long indeed. These axons running from your spiral cord and the way to your big toe. You could think of it to release a size of things in the terms of a basketball and a 40 mil garden hose. Surrounding the axon in what's called a Miller sheds. The Miller sheds, and you can think of it as insulation as 13 teeth, like insulators on a wire. So the information comes through the dendrites and summed up the cell body, and it's transmitted through the axon. So what neurons do is they sum up and transmit information, and we know that there's a lot of them. By some estimate, the 100 billion of the estimate tend to be different and very right, but there's billions upon billions of neurons, and each connect to thoughts, maps stand of thoughts of other neurons. So the fact then you have something in this degree of complexity, this degree of structure, which there no way to replicate in a many machine. The numbers are just too big in why people might describe the brain as the most completed machine in the universe. At least when the fleeting is made of meat, maybe. which is kind disappointing, but at least it shows its incredible internet structure. So neurons come in three flavors. There are sensory neurons which think information from the environment, from the external world. These motor neurons which go from the brain out to your motor control. So if you touch something hot and you feel the pain, that is sensory neurons. If you rent your hand back, you reach for something, that's motor neurons. Finally, race internationals which connect different neurons with making contact with international world. Either thought, that sensation, or thought, motor action. Now the main thing to think about for neurons and neuron fearing is that it's all the nothing. It's like fearing a ground or sneezing. Neurons either fire on the don't. Now you might think that's a little bit strange, particularly when you think about sensory neurons, because your experience seems to be a continuum. So you have sensory neurons in your eyes, and you can distinguish from a very deep light and a very bright light. You have sensory neurons in your fingers, and you could distinguish between gentle touching something versus being stable in the tip of your finger or something. But still the neurons are all or nothing. The way we get to this continuity of experience is that neurons can code for intensity in different ways. So one what determines of the number of neurons that fire. If X neurons corresponds to emit experience X times 10 neurons may correspond to an extends experience. Another factor in the impulses frequency of individual neurons, and individual neurons might render a mind sensation by doing fire, fire, fire. Well, it might denote an instant situation with fire, fire, fire. So you have neurons, and the neurons talk to each other. They talk to each other because axons of the neuron with communication with the dendrites of another neuron. A long time ago, people used to think that neurons were wired up together like a computer, but in fact, neurons don't actually touch one another. There is a gap between the axons terminals of one neuron and the dendrite of another one, a very tiny gap, typically of like 1/110,000 of a meter wide. This gap is known in the synapse. When neuron files the axons released neurotransmitters, the chemicals that shoot out over that gap and affect dendrites and other neurons. As I said before, the effects of these neurotransmitters could be excitatory, which is that they raise the energy, so they increase the likelihood of a nervous feeling of exhibitory, so that they bring down the likelihood of a neuron flaring. What's interesting is that different neurons shoot out different neurotransmitters, so that different effects on other neurons that they might contact with in effect a lot of psychomatology. Both attempts to cure various psychological or physical disorders by giving medical of prescription psychopharmacology designed to increase pleasure of different forms of something, help people work of or help people focus, works by freezing with the neurotransmitters, and this can be either antagonist the lower down intensity of things by building to the dendrites, make it hard to create more neurotransmitters, or they can increase the amount of neurotransmitters available in different ways agonist. So you either pumping up the volume or turning down the volume. So you think about different drugs and their effects. This a courier. Courier is the drug that used by South American Indians. It's an antagonist. It blocks motor neurons from affect their mist fibers. It keeps your motor neurons from working, and what it does in the paralyzed you, and in large enough doses it kills you, because motor neurons also keep your heart beating. So shoot the down and you die. This alcohol also has one inhibitory effect. You might think that strange, because when I drink alcohol I get an excited and happy and goofy. But you have to keep the mind here. The way alcohol works in inhibiting part of your brain that does exhibition. So you have part of your brain that says, don't say that the other person, keep your pants on, stop yelling, and alcohol basically inhibiting that part of the brain, makes you more exuberant. Then over the course of things, in the course of drinking too much, it also inhibits water parts of the brain, so you could pass out, the fall in the floor, and large another does die. So both courier and alcohol in different ways brightening down. Other drugs bright things up. So ampere times, for instance, inscribe the amount of NEPR1, which in another neurotransmitter that's responsible for generating general aerosol, and this is how drugs like speed and cocaine work. Other drugs like Prozac of L-Dopa influence neurotransmitters in a way that they inscribe, for instance, the supply of dopamine or serotonin, which can be relevant for insight like Parkinson's, which seem to be related to like dopamine, and depression, which is related to little serotonin. So these drugs work by influencing neurotransmitters, aided by differently pumping is more neurotransmitters, and inscript the supply in different ways of stopping them from having effects by binding them or sucking them up in different ways. But they work on the effects of neurotransmitters. So the more general idea is the way neurons lead to thinking is that they form clusters or networks. There's clusters and networks are computation devices that do interesting things like recording phase of walking upright or understanding senses or doing math on experiencing great sadness or falling in love and so on. We now know that that's possible because we create completing machines that work in certain ways. That if you wire a completing machine in certain complete ways into the magical play chess, do flight similar, and so on. So you may be interested in the project of computational neuroscience, which tries to ask the questions how our nerves wire up to do interesting things, and used our one senses of computational there as a model. Then sometimes takes the inference the other way around, which is you can see how people do it and then use the knowledge of how people do it to create computational systems that can do it as well. So how the brain wired up? Well, you might imagine what is wired up like a portable computer, like a laptop, like the sort of computer you're looking at now. It sounds garage it is, but there are a couple of reasons why it can't be, and both them have to do which how well the brain works. So first, the brain is heavily resistance to damage. If you get a knife to the brain, if you get damage to the brain, it would typically shut down the whole system. The information and the cartoon sample described it across neurons in such a way that makes them extremely resistant to damage. Well, in contrast, somebody can open up the back of your laptop, pull out the chip, and while this right, the whole things will stop working. But the brain is wired up in a certain way that makes it highly resilient. The second thing is the brain is wired up in such a way that makes it work very fast. So computers can do millions of operations per second because they're purely electrical. But brain is much slower and can spend the time to do many steps. So to put it a different way, if your brain was wired up like a computer, it would be so slow as to be entirely unusable. It's how to be wired up in a way that's more effective, that allows for the slowness of brain tissues and neurotransmitters, and can still compute things at a human level, which is often blindingly fast. Because of this, there has been a huge interest in massively parallel systems and completely neural networks, which are wired as we believe the brain does, and as such, we are helping computers to do things based on your understanding of the brain that they could never do before. The details of things is something we're doing to talk about things the course. We're not actually doing to the up explaining different characteristics differently in terms of neurons, because we can't, and because we want to have 100 level explained that. So when I talk about how people learn language, or how do they recognize face, we're not going to talk much about neurons in particular, but we will talk about different brain areas and how they work. Then the acceptance is the bet that's everything we talk about in more fiction ways can ultimately reduce down to large networks of neural system, and this in turn we're going to talk much about neurons in particular, but we will talk about different brain areas that work. Then the acceptance debate everything we talk about in a more fictional ways can fundamentally reduce down to large networks of neural system, and in turn will ultimately reduce down to the specific behaviors of the specific neurons that we're looking at.